Hello everyone, welcome to today's webinar. We're gonna go over the second section of Unit 5, Quadratic Equations. Today we're gonna look at how to solve quadratic equations. For that, we need to learn how to factor equations, and then we'll look at how to solve the equations. This is myself. My name is Miriam. I'm your math instructor here at Penn. I'm certified to teach math in the state of Pennsylvania, and also I have my master's degree in education. In this webinar, we're going to cover the most challenging topic in the second section of Unit 5 as we know here. And also, during the webinar, we're going to have some discussion on certain types of trinomials and equations, how to factor them, how to solve the equations, but also we're going to have some self-check questions after each section of the webinar. So those questions are not graded. Those questions are given for you to do the questions themselves yourself and see if you got the idea or you have some questions that you want to share with everyone here during the webinar. Your questions are welcome. Of course, please keep them relevant to what we speak about during this webinar. You can type in your questions in the questions box. The raise your hand feature is not enabled in our webinars. Also, all registrants will receive a recording of today's webinar for their future reference if they would like to watch it one more time before they go ahead and take the exam. In this webinar, we're going to look at how to factor trinomials, how to check if a trinomial is factorable or no, if you're able to factor that or no. And also, we're going to use factoring to solve quadratic equations. And we're also going to look at the standard quadratic formula and how can we use that as a second method to solve equations. Let's start by having things here defined. What is a trinomial? A trinomial is a polynomial like you see here. This is 1, 2, 3 terms. So anything that's more than 2 terms, we call it a polynomials. In this case, also, it's 3 terms, so we call it a trinomial. Now, a quadratic trinomial has its degree as a second degree trinomial. And that because that the highest degree in this polynomial is 2, so this is a second degree trinomial. We will look at how to factor this trinomial. Also, a quadratic equation is just a trinomial with an equal to 0 added to that. So this will make it an equation, but it's the same thing as a quadratic trinomial. It's just in the form of an equation. Let's look at how to factor then. If we are given a certain trinomial, and the ultimate goal in this webinar is not only to know how to factor trinomials, is to use those methods to solve quadratic equations. So we're going to go step by step and see how can we factor trinomials first, and then we're going to go ahead and utilize that in how to solve quadratic equations. So if you're given a trinomial like that, what are the steps that we need to do in order to factor a trinomial? So just to give you an idea of the process. So if I give you a number away from that question, if I give you a number like 20, for example, and I ask you to list the factors, what are the factors of 20? Factor 20, what would you say? Well, you're going to think about what would be two numbers, you multiply them together, and you get 20. So 1 and 20, for example, are a set of factors, 2 and 10, and so on. The same thing, we're going to treat that trinomial. We will be looking for two binomials. When you multiply them together, you get back the trinomials. Those two binomials are the factors of the trinomial that you see here on those slides I'm going to share as part of my webinar. So our goal is to find the factors of the trinomial. But then how can we do that? To factor a trinomial, I need to look at C. C is the last number here appears on the trinomial. I need to think of the factors of 18. I need to think about the factors of 18. I have a condition which set of factors of 18 I should pick. The condition is if I add those two factors, I should get the B, which is the 9. So again, I'm going to repeat that. So I'm going to list the factors of 18 and then pick the set of factors that when I add them, it should give me a 9. So let's do that. So I'm gonna call one of the factors of 18 P and the other one is Q. I'm looking for the factors of 18. So I'm gonna think about 1 and 18. This is one set of factors. Another one is 2 and 9. Another one is 3 and 6. Now, which one of these sets, when you add them, you get a 9? 1 and 18 is 19. That's not the right one. 2 and 9 is not the right one. 3 and 6 is the set of factors I'm looking for. 6 and 3 is 9. So this is what I'm going to use to write out my factors for the trinomial. The way I'm going to do that is I'm going to open up two sets of parentheses here. I'm going to have an x and an x. Later on, you will see those signs may change. But for now, because we have a plus and a plus, and we know that positive 3 times positive 6 will give you positive 9, then the signs that will appear in my factors would be a plus and a plus, since both factors here are positive. And then place the 3 and the 6 here. So x plus 3 and x plus 6 are the two factors I'm looking for this trinomial. On this side of the slides, I summarized the rules that we go by. So if you want to write them down in your notebook or on whatever paper you keep for each lesson, or if you print out the study units, you can make a note of that. So you have a summary of what to look for, what to do to factor a trinomial. Let's do another one. Now, I see the signs are different. I have a minus and a plus. So when you have a minus and plus, let's then list the factors and think about the signs. Okay, so I'm looking for factors of 20. When I add them, they should give us negative 12. So the first step I'm going to do is to list the factors of 20 P's and Q's. I have 1 times 20 will give me the 20. Also 2 times 10 will give me 20. I also have 4 and 5. Remember, I'm looking for factors of 20. When I add them, it should give me a negative number. It means that both of the factors in each set has to be a negative number. Let's check what we mean by that. So negative 1 times negative 20 will give me the 20. And then when you add, you will get a negative answer. Now, the issue is what would be the set of factors that will give you a negative 12? It's not going to be the first set. It's going to be the second set. And the reason for that is negative 2 times negative 10 will equal to the C, which is 20, positive 20. Remember, negative times a negative is positive. And also negative 2 plus negative 10 will give you negative 12, which is the B. So that's why I said that negative 2 and negative 10 would be the numbers appearing in our factors for this trinomial. How I'm going to write it out here? Two sets of parentheses, x and x. And since both the 2 and the 10 are negative, I'm going to have a minus sign and a minus sign. And then write out the numbers 2 and 10 or 10 and 2. It's not going to matter because the signs are the same. So the factors of this trinomial is x minus 10 and x minus 2. Any questions so far? Anything that was not clear? Okay, the raise your hand feature is not enabled. If you want to share your questions, you can type them in the questions box. Let's go to another two sets of trinomials that we have some signs that we need to figure out how can we write the factors for a trinomial when you have a plus and a minus sign. Okay, we're going to do the same thing. I'm looking at the 24. What are the set of factors of 24? So I'm going to do the P's and the Q's. 1 and 24 is a possibility. I have 2 and 12. I have 3 and 8. And finally, I have 4 and 6. Look at the 24. I'm looking actually for the factors of negative 24. So one of those factors has to have a negative sign because negative times a positive will give you a negative product. But which one? Is the 1 or the 24 will be the negative? We need to think about the B. When you add those two factors, whichever you're going to decide on, the sum has to have a positive sign. We know that when we add two integers with different signs, we subtract and give the answer the sign of the larger number. It means in this case that the larger number will be a positive number. So those numbers will be positive. So these factors, the smaller factors, the one that has lower values would be negative. They has to be negative. Okay. Now we need to think about which set of factors. 24 times negative 1 is negative 24, but when you add, it does not give you positive 10. So this is not one of the options. Negative 2 times positive 12 is negative 24. When you add them, negative 2 plus 12, the answer will have the sign of the bigger number, which is positive, and then subtract. That will give you 10, positive 10. So this set of factors are the ones I'm looking for. Once again, I'm going to write out the factors in two sets of parentheses, x and x. One factor is negative. I'm going to have a minus sign, and the other one is positive. Okay, so 2 was negative. It goes with the minus sign. 12 was positive. It will go with the positive sign. Those factors are x minus 2 and x plus 12. I know it's tricky, confusing, too many steps, but when you practice a lot, you will right away know what you should do, which factors has to be negatives, and which ones has to be positive. Number 4, x squared minus 7x minus 30, factor. Then I'm looking at the 30. What are the factors of 30? In reality, I'm looking at the factors of negative 30, but I'm going to go with the positive 30 factors first and then decide which numbers will have a negative sign, because I have a negative sign here and a negative sign here. Those two factors, when you multiply them, it should give you a negative 30. Then one should be a positive, one should be a negative, but which one? Since you add them and the answer gives the negative sign, then the bigger factor will have the negative sign. Let's do that. P's and Q's. So 1 and 30 is a possible set of factors. 2 and 15. I have 3 and 10. We have also 5 and 6. Okay, now 1 is positive, 1 is negative. When we add, it's a negative answer, then the bigger numbers should be negative. Okay, so if I look at 3 and negative 10, let's make sure that this is the right set of factors. 3 times negative 10 will give you negative 30. Check. And 3 plus negative 10 will give you negative 7, and check. So this is the set of factors I'm looking for. Write out the factors for the trinomial. X minus and x plus. The 3 is the positive and 10 here is the negative. That's it. Any questions? Anything that you think is confusing about the way that we factor trinomials? As long as you have the reasoning on why you choose a certain set of factors, on why you choose certain signs for those factors, you will be on the right track. If you try to memorize, here will come some confusion because I mean it's minuses, pluses, factors, and it's going to be a lot to memorize. Try to reason why you have a minus and a plus and why the bigger number is a minus or a negative because the sum of that is negative and so on. This is the best way to do the factoring, to remember the factoring. Whenever you practice a lot and use the reasoning a lot, it will become a second nature. Whenever you see a trinomial, you will know what to do right away. Okay. I have a self-check question, and that would be on the same topic that we have been speaking about. Before we go to the self-check question, I just wanted to give you a summary. If you wanted to memorize, that would be just a cheat sheet for that. I recommend that you do the reasoning, but this summary tells you if you have a positive b and a positive c, both factors will have positive. Negative b and positive c, both factors will have a negative. Positive, negative, you have negative and positive, but the q is the larger number, should be the larger number. And if you have a negative and a negative, then negative and positive, but in this case, p would have the larger value. And I also included a review from General Math 1, which is one of the basic courses that we have on how to add signed integers. So if you want to write this down somewhere, when you add positive and positive, what happens, negative and negative, what happens, and then positive and negative, that will help you with determining which factor would be the negative and which factor would be the positive. Let's do another question, but I'm going to let you do that question yourself first, and then we can go quickly over that question. So again, self-check questions are not graded in this webinar. I'm not going to keep track of who did that correctly or not. This is a self-assessment question. You will assess yourself and see, did you get the idea, or you have maybe more questions, or you want to make an appointment and speak to a teacher assistant or an instructor and so on. So what I'm going to do, I'm going to change my screen and give you that question and also a chance to share your answers. Here you go. How would you factor this trinomial? X squared plus 12x minus 28. Remember the P's and the Q's. I'm going to be quiet for a minute or so you can apply what we have learned so far. Okay, I'm gonna close this question. I'm gonna get you back to the slides, and I'm gonna go ahead and do this question. Usually, I do not go over these questions in details, but I know this topic is the toughest topic in the whole course. So I will spend extra time in that topic just to give you the idea. So now, x squared plus 12x minus 28. The first step I'm going to do, list the factors for 28. In reality, remember, we are listing the factors of negative 28. And since it's a negative product, one of the factors would be negative and the other one would be positive. But I'm going to start with positives first and then decide on the signs, P's and Q's. Well, 28 I think about as 1 times 28, 2 times 14, and I have also 4 times 7. Okay, Now we're listing the factors of negative 28. But when we add those factors, the sum is positive. That tells me that the larger number in that set of factor has to have a positive sign. So the Q's would be the positive, the P's, the smaller factors, would be the negatives. Now decide on the set of factors. Which one would work? Well, negative 1 plus 28 is 27. That's not correct. That's not the one I'm looking for. I'm looking for the sum of positive 12. Well, negative 2 plus 14 is positive 12. Then I'm going to write out my factors for this trinomial as x minus 2 times x plus 14. Then the right answer for that would be B. B is the correct answer. Remember, if I'm going to write the set of factors as x plus 14 times x minus 2 or x minus 2 times x plus 14, as long as I have the correct sign with the correct number, I can switch positions. I can say, well, x plus 14 times x minus 2 or x minus 2 times x plus 14. They are multiplied, so you can switch. Any questions here? The answer, Tiffany, was B. B as in boy. I just circled the right answer in purple. I hope that you are able to see my screen. So the answer is B. These are the correct factors of the given trinomial. As I said, reasoning the steps before you do them, try not to memorize as much and practice a lot. It will become easier. Okay, let's move on to a little bit tougher kind of trinomials when it comes to factoring. Now, so far, I'm going to go back here. So far, the a, which is the number that is multiplied to our x, was 1. It was 1 all the time. So for that, we learned this method to do the factoring. What if things get complicated and we have a number or a coefficient for x squared that's not a 1, like a 2, a 4? What should we do? So to do that, I have gone through the study unit. In the method that they are discussing in the study unit is trial and error, trying to find the factors of 2, the factor of 72, and then try to mix and match the factors and do the FOIL every time you come up with a set of factors, and then try to see if the FOIL method will give you back the same trinomial as the one originally given in the question. If it's not, then try another set of factors. For me, it's a method. You can go with that. My method, and I actually have to be honest with you, I did not invent that. I just learned that from my teacher when I was in high school. So I give her credit for teaching me a good and kind of easy way to factor this kind of trinomial. Remember, whenever you have a does not equal to 1. Okay, I'm going to go ahead and show you how to do that. The first thing I'm going to do, when I have the steps, by the way, here too, if you want to read them too, I'm going to multiply a times c. So a times c would be 2 times negative 72, which is negative 144. So I'm going to rewrite the trinomial as x squared plus 45x minus 144. What I did in the first step is I just multiplied 2 times negative 72. So I just deleted the 2 in front of the x squared and put the product at the end as the new c in our trinomial. Now, this looks familiar to us. We know how to factor this kind of trinomial when you have an a equals to 1. So the same steps, p's and q's. I'm going to list the factors of p's of 144, and remember it's negative 144, but I'm going to start with the positive 144. I'm going to think about 1 and 144. I'm going to think about 2 and 72. Also, I have 3 and 48. I also have 4 and 36 and so on. Let's try the ones that we have here. If we need more, we can go down the list. 1 and 44. Now, I see that it's a negative 144, so one factor should be a positive and the other one should be a negative. Which one? Well, the sum is positive, then the bigger values of those factors should be the positive, and those ones should be the negatives. Okay, which one then, when we add them, it gives us 45, positive 45. You will realize it's going to be 3, negative 3, and 48. 48 minus 3 or negative 3 plus 48 will give you positive 45. Now let's write the factors. I'm going to have an x, and I know one is negative and one is positive. The negative one is a 3, the positive one is a 48. Now the tweak that we have, because we have that leading coefficient, I'm gonna multiply the x times 2 and the x times 2. I want to color code that because this is an important step in our method here. 2 and 2. I just brought in the coefficient that appears in the original trinomial before the x squared. I'm gonna bring it into the x here and to the x here. I'm gonna multiply 2 times x and 2 times x. Next, the next step is I'm going to look at factoring out a greatest common factor. If you're not able to remember how to do that, please refer to the first webinar for this unit. We went in details on how to factor out the greatest common factor from a binomial. This is a binomial and this is another binomial. We'll look at the 2 and the 3. Is there a common factor between 2 and 3? The answer is no, because both of them are prime numbers. What about 2 and 48? Yes, there is a common factor. I'm gonna then keep the factor 2x minus 3 as is because I cannot do anything about it. I cannot factor out anything from that. But I can factor out 2 out of this binomial. Remember, when you factor out a number, to figure out the rest of the expression, you need to divide. 2x over 2 is x. 48 over 2 will give you 24. Okay? Next, the next step, delete this greatest common factor. I do not need that in my factors. I added the 2 times x and 2 times x, and then I realized that this 2 is extra. It's not needed. So delete the 2. Now your factors of this trinomial are 2x minus 3 and x plus 24. Now you can do the trial and error and try to see which set of factors will go there. But remember, the 72 has lots of factors. So you need to really do a hard job with the trial and error, and you have to do it correctly in order to arrive at this set of factors. But this way, it has certain kind of steps. You follow them, you get to the answer right away. Okay, now let's do another. Well, you know what? Let's do the FOIL method. I want to show you how would you make sure that you have arrived at the right factors, especially when you are factoring trinomials with the leading coefficient here. So let's do the FOIL. FOIL is what we use to make sure that our factors are correct. So FOIL would be multiplying these two factors together. So 2x times x is 2x squared. 2x times 24 will give you 48x, and then negative 3 times x is negative 3x, and then negative 3 times 24 will give you negative 72. Combine like factors, combine like terms. So 2x squared. These two are like terms. If you want to refer to Unit 1 webinar, we went over how would you combine like terms in a polynomial. 48 minus 3 is positive 45x, and then minus 72. This is the same as the original trinomial. This is how you make sure that you have arrived to the correct set of factors. Any questions? Okay, let's do another example using this method. Okay, 4x squared plus 8x plus 3. I see a leading coefficient here. I need to use the special method that we just learned. Okay, the first step, multiply 4 times positive 3. It's a 12. Rewrite the trinomial x squared plus 8x plus 12, because 4 times 3 is 12. And then I'm going to just factor as usual. I'm going to list the factors 12, so when you add them, it's an 8. Okay, I have P's and Q's. I have 1 and 12. I have 2 and 6. Oh, 2 and 6. Well, 2 and 6 is what I'm looking for. Okay, rewrite the factors so you include them in the actual factors of the trinomial. I have an x, and both are pluses. Then everything should be easy here. Plus and plus. I have a 2 and I have a 6. I'm going to add the 4 times the x and the 4 times the x. Next, factor out the greatest common factor from each binomial if possible. I have a 4 and a 2. The common factor between 4 and a 2 is a 2. Take it out. So take that out. 2 times. So divide. 4x over 2 is 2x. 2 over 2 is 1. Times 4 and 6. The common factor, the greatest common factor, is another 2. 2. 4 over 2 is a 2x plus 3. Remember, those 2's that we have taken out of each binomial, they are extra. They are not needed. I just need to cancel them. And then write your final answer. Your factors are 2x plus 1 times 2x plus 3. You're not sure? Do the FOIL. Let's do that together. Just to have a habit of checking your answer, especially with a leading coefficient. 2x times 2x is 4x squared. 2x times 3 is 6x. 1 times 2x is 2x, and then plus 3. Okay, combine like terms. 4x squared, 6 and 2 is 8x, and then plus 3. This exactly matches this trinomial, so these are your correct factors. Any questions? Okay, let's do another example with big numbers and see if that method will stay valid. 45x squared plus 60x plus 20. Come on, if you're going to do the trial and error method, how many factors you have for 45? And you have to mix and match with the factors of 20. That would be an endless amount of work that you have to do. If you had done it correctly, you'll be able to find the answer. But let's do our method. Okay, so multiply. Well, before I multiply, actually, I need to make a note here. 45 and 60 and 20, I am thinking that these three numbers has a greatest common factor in between them. So to make it easier for me and to lower those coefficients, I can just factor out a greatest common factor and keep it, because that would be part of our answer. 45 and 60 and 20, the greatest common factor wouldn't be 10, because I have that 10 common between 20 and 60, but not the 45. But 5 is a greatest common factor between 45, 60, and 20. And again, you can go to webinar 1 for this unit to know exactly the manual way to figure out the greatest common factors between three numbers. But for now, it's 5. This 5 is not going to be canceled. This 5 is part of our answer. 5 will be a third factor for the trinomial. And then divide. 45 over 5 is 9x squared plus 60 over 5 is 12x. And then 20 over 5, it's a 4. Now I'm gonna just ignore the 5 for now. I have it in my answer. I will have it in my answer. Just look at this trinomial and let's do the steps then. Number 1, multiply 9 times 4 is 36. So I'm gonna keep my 5. I need it. So I'm gonna have x squared plus 12x plus 36 because 9 times 4 is 36. Now my C is a 36, my B is a 12. List the factors for 36. So P's and Q's. I have, of course, 1 and 36. I have 2 and 18. I have also 3 and 12. I have 4 and 9. That's a 4. I have also a 6 and a 6. Okay, which one would be positive? Which one would be negative? Actually, both of them would be positive. Then that's it. Okay, which one, when I add the numbers in that one set of factors, will give me 12? 4 and 9 will match my requirements here. 4 and 9 is 12. So I'm going to keep the 5. And then factor. I'm going to write out my factors. I have an x and I have an x. And I have plus 4 and plus 9. Both of them are positive. Remember, I have a 9. I'm not going to put the 45. I have my 5 that I just factored out. So I'm going to put a 9 and a 9. Okay, factor out a greatest common factor from both binomials. I still have my 5. I'm not going to cancel it out. This is part of my solution. Okay, 9 and 4, nothing common. So this factor will stay as is. So far I have 1, 2 factors. The third factor, I see a 9 common between 9 and 9. So I'm going to factor out the 9. And then I'm going to write out the third factor. So 9x over 9 is an x plus 1. And I do not need this 9. This is extra. Okay, so the set of factors that you have for this trinomial, in this case, 3 factors. 5, 9x plus 4, and x plus 1. For your, if you want to say it homework, you can use FOIL, and you should be able to get back to the original trinomial, 45x squared plus 60x plus 20. Any questions? Okay, Tiffany is asking to go back. Which question, Tiffany, that you need to go over? Is it question number 2? When you have like a trinomial that you need to factor with a leading coefficient, or which question exactly that you need help with? 2, okay. So do you have a certain question on number 2? I'm going to go back here. Okay, oops, back. Okay, number 2. Do you have a question on any of the steps that we have on the screen for this question, Tiffany? Okay, I'm just waiting for Tiffany to respond. Okay, Tiffany, you don't have to write down the answers. You will get a recording of the webinar. So even if you attend or you're absent today, you weren't able to make it today, you will get the whole recording of the webinar. You can pause the video and write down everything that you need to keep as notes for you. Okay, let's go then to a self-check question, the same topic, 3x squared plus 4x minus 15. How would you factor a trinomial with a leading coefficient of 3, b is 4, and c is negative 15? I'm going to put the question up for you, and please make an effort to participate. It's not graded, I know, but it's good to have some kind of interaction. It's good to see yourself and assess, are you okay with the topic, or maybe you have a question. Okay, here you go. Okay, so let me share then my work for that question. So you have the steps for this question as well. I'm glad that I see more people participating in those questions. I appreciate that. Okay, so let's go back to the slides. Now, I'm going to follow the same things. Now, if you are in a SAT or ACT exam and you're trying to save time and decide on the answer really quickly, I mean, without having to do like a manual workout for each question, I'm looking at options A and B. It tells me that 3 is a common factor. And 3 is a common factor. Remember the last question that we did? We factored out the 5 because the 3 terms had a greatest common factor 5 in between them. Look at 3 and 4 and 5. Is 3 a common factor, a greatest common factor between 3, 4, and 15? And the answer is no. We have a 4 here. I mean, 3 and 15, they have a greatest common factor of 3, but the 4. So without doing anything here, I'm going to just ignore these two answers. Okay, now the thing comes with which factor I need to do. All right, I mean, which set of factors are true. Okay, so at this point, we have to do the whole thing. So multiply 3 and 15. That will give you 45. So x squared plus 4x and then minus 45. Look at the factors of 45. You will realize that negative 5 and positive 9 would be the correct ones to consider. So x and x, I have a positive and I have a negative. Okay, since I'm going to add them, it's going to give me a positive sum here, then the bigger number 9 would have the positive sign, and the other one we said is going to be a 5. Okay, I need to add the leading coefficient for both binomials. So I'm going to have a 3 and a 3. Okay, factor out the greatest common factor from each binomial if possible. I see 3 and 9. 3 is a common factor, then it's going to be x plus 3. 3 and 5, nothing common, then x or 3x minus 5. And then this 3 is extra. I do not need that. Don't confuse yourself with when we have a common factor factored out at the real beginning of the trinomial to make my numbers easier to work with, and the extra factor that I write in front of the x, and then I have to eliminate if it happens to be a greatest common factor. So this 3 is not part of our answer. So the 3 is positive and 5 is negative, and this has the 3x. The answer is C. C is the right set of factors. And you can do the FOIL to make sure that you can go back to the exact trinomial that you started with. If you did not, then you have done something wrong, maybe with the signs. Okay, let's go to the next section. Now, factor x squared plus 5x plus 29. What should I do? I'm going to do the same thing, P's and Q's. The only factors for 29 are 1 and 29. 29 is a prime number. and both signs are positive, then the only set of factors I have for 29 is 1 and 29. Add them, it's 30, and 30 is not b. This trinomial is not factorable. Not factorable. So if you happen to do everything that you're supposed to do, but you cannot come up with the right b from the factors, then this trinomial cannot be factored. The same thing with here. If you do the steps, you realize that you cannot factor this trinomial. That's it. So if it happens, just don't doubt yourself if you have done everything correctly, and you cannot just find anything to write as factors for those trinomials. Okay, next. Now, the ultimate goal of this webinar is to see how to solve a quadratic equation. As I said in the beginning, a quadratic equation, just a trinomial, and it has an equal sign and then a 0 on the right-hand side of the equation. To solve a quadratic equation, we need to factor the equation, and we just learned how to do that. And then we're going to do an extra step to find the values of x that would make this equation correct. So I'm going to factor. So first step, I'm going to factor. I'm going to factor the trinomial. I'm going to keep the equal to 0 because I'm factoring a trinomial, but it is an equation. I have to keep my other side of the equation. I'm going to do x and x. I know it's a minus and a minus. With practice, you will know, but for now, you can do the manual way. P's and Q's. Look for the factors of 50. They add up to a negative 15. You will end up with a negative 5 and a negative 10. Okay, so we factored the equation. What's next? The new step that we have to do to solve the equation is to use the zero property. The zero property for numbers, if you remember, and it's a second nature for us, but it's a property for numbers. For example, 3 times 0 is a 0, right? Anything times a 0 is a 0. So if I multiply this factor times that factor, it should give me a 0 according to the equation. Then it means that either this factor is the 0, so 0 times whatever factor is that will give us a 0, or this factor is the 0. Maybe this factor evaluates to a 0. So whatever value this is times a 0 will give us a 0. This is the zero property. So this is what I'm going to use actually to find specific values for x. So I'm going to take the first factor. I say, well, maybe x minus 5 evaluates to a 0. You have a simple equation. Solve. Add 5 and add 5. Cancel out the 5's, x equals to 5. That's the first value of x. Or the other option is that this evaluates to another value, not 0, but this one is a 0. Then x minus 10 equals to 0. Solve. Add 10 and add 10. Cancel out the 10's. X equals to 10. You have two possibilities for the value of x. Either it's a 5 or a 10. What does it mean to have a solution for an equation? Well, it means that if you take away each x in this equation and put a 5 or put a 10, you should arrive at a 0. So these values makes this equation true. Let's try one value. Let's go with the 5. So if I'm going to test a 5 squared, because it's x squared, minus 15 times x, 15 times 5, plus 50. Does it equal to 0? Well, 5 squared is 25, minus 15 times 5 is 75, plus 50. Do your math and add, and you will find out that this left-hand side of the equation is equal to 0. Then this 5 is a correct value of x. If you try it for 10, you will have a 0 on the right-hand side. So this is another value of x. And that's it. So your solutions are 5 and 10. Okay? Let's look at another way to solve equations without having to factor the trinomial. You can factor the trinomial if you're able to, but there is a standard formula for those situations when you have factors that is difficult to find out yourself using the list of factors of 36, for example. Okay, the formula that I'm referring to is the quadratic formula. This formula works for any trinomial. For any trinomial. What you need to do is to, one, not to try to memorize the formula. Try to have the formula written out on a piece of paper as a reference sheet. So when you use the formula, you are not using the wrong formula. See, there is lots of signs there, squares, b's, and a square root sign. Please do not recall that from your mind when you're doing a practice question or the exam. That's one. Two, identify b's, a's, and c's. The formula is negative b. The b is actually this value. Remember, it's x squared, or ax squared plus bx plus c. Identify the b's and the c's and the a's from the given trinomial. So minus b or negative b plus or minus, because we have two solutions, the square root of b, the square of b minus 4ac over 2a. Okay. How can we use this formula safely? So the first step, list the values of a, b, and c from the trinomial. A in this case is a 1. Remember, we do not write 1 in algebra, but it's understood that there is a 1 there. B is negative 20. Remember, negative 20. And then C is 36. Plug in the numbers of A, B, and C in the formula and do the calculations correctly. You will find the value or values of X. Let's do that together here. So X equals to a negative. Well, this negative here is part of the formula. I'm not going to be able to just delete that. It has to be there. And negative whatever the value of B. Well, B is a negative number itself. Well, I'm going to do negative 20 because B itself is a negative 20, but we have a negative in the formula. This is a common mistake in using this formula that I often see with students. Plus or minus, we have two solutions, remember? The square root of b squared. B is negative 20, then you have to square the negative 20. Minus 4 times A is 1, times C is 36. I'm not done yet. Over 2 times A is 1, then 2 times 1. Okay, I just plugged in the values for A, B, and C in the formula. Next, I need to simplify. So I'm able to get to 2 values of X or 1 value of X or maybe none. Okay, so X equals to negative 20 is 20. Negative times a negative is a positive. Plus or minus the square root of. Okay, well, negative 20 squared will give you positive 400. Minus 4 times 1 is a 4, times 36 will give you 144. Over 2 times 1 is 2. Simplify further. So I have 20 plus or minus 400 minus 144 will give you 256 still over 2. Simplify more. We hope that the 256 is a perfect square, so we'll be able to take the square root of that and will give us a whole number. So if you use your calculator, you can find out that the square root of 256 is 16. So 20 plus or minus 16 over 2. At this point, I need to do 2 arrows here. Once, I'm going to add 20 plus 16 over 2. And the other option is 20 minus 16 over 2. And that's why we have the plus over the minus here. Okay, evaluate each expression. 20 plus 16 and then over 2 will give you 18. And the other option is 20 minus 16 over 2 will give you 2. Your two values of x are x equals to 18 and x equals to 2. So by using this formula, I did not have to factor. I just plugged in the values of a, b, c given in the trinomial, and I did my calculations correctly step by step, and then I was able to come up with two solutions. Is it going to be two solutions always? The answer is no. You may end up with one value of x, two values of x, or no value at all. Now, would you be able to factor then? I mean, do you have to use the formula, or you're able to do the factoring, and are you going to be able to find the same answers, 18 and 2? And the answer is yes. I just want to show you on the side that there's another way to do that. So it's an option for you if the trinomial is factorable, or if you're able to find the factors of that. Okay, so I'm going to do that on the side just to show you that both methods are equivalent. It just depends on the difficulty of the numbers that you have on the trinomial. We're going to figure out that the negative 18 and negative 2 would be the factors. So factors would be x minus 18 and x minus 2. And negative 2 times negative 18 will give you the positive 36. Add, it will give you the negative 20. Okay, zero property. Either x minus 18 equals to 0, and that would mean that x equals to 18, or x minus 2 equals to 0, and that would mean that the other value of x is 2. 18 and 2, 18 and 2. In this case, this trinomial is factorable. I was able to find the factors. The factors are whole numbers, negative 18 and negative 2. So I had the option either to go with our old method, factoring, or to use the formula. Any questions? Okay, let's go on to another example. What if we have a leading coefficient of the trinomial? Nothing will change. I can go ahead and use the formula, or I can go ahead and try to factor. So you are able to factor this trinomial. You can try that on your own time to use the factoring method. But let's try the formula one more time. The first step, I'm going to copy down the formula correctly without trying to recall it from our mind. We need to copy it down from the study unit or a cheat sheet that we keep. 2, find out the values of A equals to 2. This is the A. B equals to 3. And C equals to 1. 3, plug in the numbers correctly in the formula. Then X equals to negative 3, B is 3, plus or minus the square root of B squared, so it's going to be 3 squared because B is 3, minus 4 times A, which is 2, times C, which is 1. And then over 2A, so it's 2 times 2. Simplify. I have negative 3 plus or minus the value or the expression under the square root sign. It is going to be 9 because 3 squared is not 6. It's 9. 3 times 3. Minus 4 times 2 is 8. And then times 1 is still 8. So 9 minus 8 over 2 times 2 is 4. Simplify further. Equals to negative 3 plus or minus the square root of 1 because 9 minus 8 is 1. And then over 4. At this point, I'm going to consider two options. Either 3 plus the square root of 1, which is 1, over 4, or 3 minus 1 over 4. Okay, so 3 minus 1 is 2. 2 over 4 is a half. Half is one of the values of x. 3 plus 1 is 4, and 4 over 4 is a 1. Then x also can be 1. Then our final answer, x equals to half, and x equals to 1. Okay, I see something I didn't do right. It's a negative 3. It's a negative 3. So negative 3 minus 1 is, I'm sorry, negative 4 here. Negative 4. I'm sorry, I'm going to rewrite that. So negative 3 minus 1 is a negative 4. Negative 4 over 4 is a negative 1. Negative 1. Okay, let's redo the second option. Negative 3 plus 1 is a negative 2. Negative 2. So negative 2 over 4 is a negative half. Is a negative half. You feel good when your teacher do some errors there. So it's negative 2 over 4. It's going to be a negative half. So our answers are either negative half or a negative 1. A negative half or negative 1 would be the options for x. If you want to try the factoring, I'm going to give you the factors, and you can try them yourselves and try to come up with those factors. So factors for this trinomial will be 2x plus 1 times x plus 1. And then you can use the zero property, and then you will find the same answers, negative 1 and negative half. Any questions? I'm going over time, but it's okay. I need to cover that one section together in one webinar. I think that's more beneficial than dividing this up into separate webinars. So next is a self-check. Use the formula, or you can factor, you can try to factor to come up with the values of x to solve this equation. 6x squared plus 5x minus 1. I'm going to keep the screen for a few seconds so you can copy down this formula in case you want to use the formula, and then I'm going to switch to my question. So it's negative b plus or minus the square root of b squared minus 4ac over 2a. And here is the question. What are the solutions for this quadratic equation? Okay, so I'm not going to go over the calculations for that, but we know our A is a 6, our B is a 5, but C is a negative 1. You're going to plug in the answers, the values in place of A, B, and C, and your answer should be C. C, x is 1/6, or x equals to a negative 1. Okay, let's move on to the last topic I want to speak about is the discriminant. The discriminant is a value that you can use to check if the equation that you have, the quadratic equation that you have has 2 real solutions, 1 real solution, or no real solutions. You don't have to do the whole formula to come up with the answer of that question. And the question is, how many real solutions this quadratic equation would have? And you'll be given a quadratic equation. In this case, you only use the discriminant. The discriminant is the value under the square root sign in the quadratic formula. which is b squared minus 4ac. So you will know your b, the a, and the c from the given equations. Do the calculations, and if the discriminant happened to be a positive value, positive, then you will know that your equation has two real numbers or two real values. If your discriminant happened to have a value of 0, then the equation that you have been given has only one real solution. If you do get an equation and you calculate the discriminant of that and it happens to be a negative value, then this equation that you have been given does not have any real solution. It has no real solution. It has imaginary solutions with other set of numbers that we do not use in our real life, maybe in space calculations and things like that, very complicated, that does not apply to everyone's real life and everyday life. They have imaginary numbers or unreal numbers. So in that case, this equation has no real solution. Okay, so let's have an example. How many real solutions does this equation have? I don't have to do the whole formula, then negative b plus or minus the square root of and over 2a. I don't have to do all of that. I just need the discriminant. Discriminant is b squared minus 4ac. What is b and what's a and what's c? A is 1, b is 2, and c is 2. Plug in the values in this discriminant formula and try to decide which or how many numbers of real solution this equation has. So b squared, 2 squared, minus 4 times a is 1, times c is 2. Okay, so 2 squared is 4, minus 4 times 1 is a 4, 4 times 2 is an 8. 4 minus 8 is negative 4. The discriminant is negative. This equation does not have any real solutions. No real solutions. It has some solutions, but they are not part of the real numbers that we know of, like fractions, decimals, and whole numbers. They have another kind of solutions. Okay, let's then do a self-check. How many real solutions in or for this equation? 2x squared minus 5x plus 3. Your a is 2, your b is negative 5, and c is 3. Can you determine the number of real solutions for this equation? Okay, I'm going to put up the question here, give you a chance to share your answer. And if you were not able to write the discriminant formula, it's b squared minus 4ac. Okay, so the answer for that question, that when you calculate the discriminant, it will give you a positive 1. A positive discriminant means that this equation has two real solutions. If you want to know the exact values of the x, then you have to do either the formula or go ahead and factor if you're able to factor the trinomial and use the zero property. That's it for my math part of the webinar. Today we went over methods of factoring trinomials. We learned how to use factoring for solving quadratic equations, and we learned how to use the standard formula, the quadratic formula, to solve the equations, and how to use the discriminant to know how many real solutions for a given equation. To prepare for the exam, do not only rely, please, on this webinar. You need to go ahead and read your study units, do discover more or practice exercises or self-checks, however they call them, within your lesson, and watch this webinar if you want. and also answer the questions for the practice questions that's within your lesson. The answer key are provided for those questions, so you can answer the questions, keep record of your answers, compare them to the answer key provided, and that way you can assess yourself and see where you stand before you actually take an exam. If you want more like videos or help on this topic, you can go to khanacademy.org. Go on subjects. It's going to be on the top left corner of the page when you go there. Select the course Algebra 1, and then you want to select quadratics. And under quadratics, you're gonna see solving quadratics by factoring, and also another topic, quadratic standard form. They have a bunch of quizzes and videos on those two topics, and these will relate to what we have gone through today. It may have extra topics, but you can just select the ones that relates to our scope of study. You can seek help by calling the school. You can schedule an appointment using this link. You can specify the day and the time that you want us to call you back, and which course and which topic that you need help with. If you have a short question and you want a kind of an instant response, you can message this number and type in learn. That will get you to a teacher assistant or an instructor. If you want a general question, you can type in coach, or if you want a student services help, you can just type in help if you have a financial question. You can email your instructor or teacher assistant, and you can do that by logging into your portal. Some of you have that kind of interface in their account, and some of you have this kind of interface of your account. You can just pick whichever applies to you and follow those steps inside each of the boxes, and you'll be able to send us an email if you have a long question and you expect a long answer or a detailed answer. Thank you so much for attending and your attention and your questions as well. There is a survey at the end of the webinar. Even the students who did not attend today, they're able to give us their feedback, what you think about today's webinar. That improves the webinar and gives me an idea what should I add in this webinar, or if I'm doing a good job, or maybe I need to improve. So if you take that survey, I'll appreciate that. 3 short questions. And I can just answer your questions if you have any before I end the webinar. Okay, well, if you don't have any questions, you still can ask your questions after we end this webinar. As I said, you can text message, you can email, you can schedule an appointment or call. I wish everyone good luck in the exam, and I'll see you then for Unit 6, which is the last unit for this course. Okay, I'm going to answer one last question, Tiffany. There is no deadline for exams. You just do exams whenever you want. So you pace yourself as long as it's a reasonable pace. You can go ahead and take the exam whenever you are ready. Good luck to everyone.